In this problem, a cannonball is fired at an angle. And we want to find how far from the base of the ship does the cannonball land. So if this is the base of the ship, we're trying to find what is delta x. So let's label what we can in this diagram. Well, the cannon is 2 meters above the water. And then it's also fired at an angle. Okay, so whenever you have a projectile motion problem and it's in two directions, what we want to do is try to break up everything into both the x and the y directions. The reason we do this is because acceleration in the x direction is going to be 0, assuming there's no air resistance. In the y direction, it's negative 9.8 meters per second squared. So we have two different accelerations. So if we can break up all of our quantities, variables, in both the x and the y direction, this might be a problem that we can solve. So it's shot 40 meters per second. That's its initial velocity. Its velocity also includes the direction, which is 30 degrees above the horizon. Okay, so if I want to find out what my initial velocity in the y and my initial velocity in the x direction are, I can take this and break it up into a right angle triangle where I have Vix and Viy. I want to find what these two quantities are given its initial speed and angle. So with a right angle triangle, we have tools that we can use: Pythagorean theorem or SOHCAHTOA. So if I want to find Vix, if this is my angle, that's my adjacent side, that's my hypotenuse, adjacent, hypotenuse, I'll use cos. So cos of 30 degrees, sub in all my values. My adjacent side is Vix. My hypotenuse is 40. So to get Vix all by itself, I multiply both sides by 40. This gives me 34.6. I can do the same with y in the y direction to find Viy. Now, this is if this is my angle, that's my opposite side, opposite to the angle, so I'm going to use opposite and hypotenuse sign. The same process. I'm running out of room here, but what we get is 20. This should be sine 30. So what we put for our Vix and Viy, plug in those values. 34.6 and 20. What else do we know? We need to know three things. Remember, all of our equations have four variables. So if I can find three of the four, I can always isolate for that fourth variable. So let's look. 2 meters above the ground. So delta y, it starts here and it goes in the negative direction, down. Down would be negative 2 meters. That's the displacement. In the x direction, well, that's what I'm trying to find, how far from the base of the ship. So look, we have three quantities in the y direction. Whenever you have three quantities, you can always find a fourth. So if we find time in the y direction, time doesn't matter about direction. Time in the x, time in the y, we can find the time in the y direction using the three quantities we have, and then use that time in the x direction. So then we'll have 1, 2, 3 variables, 3 knowns, and we can solve for a fourth variable, or our one unknown value. So let's see what equation is going to work for both of these situations. If you take out your kinematic equations, you'll find this one. this has all 4 variables. So what we're going to try to do is plug in our values and get t all by itself. So what I've done so far in step 2 is wrote my equation, subbed in all the values from my table, and then simplified this last term. So you look at this and say, okay, how am I going to solve this? You may recognize that if I have t squared t in some number, this is just like having x squared x in some number. So what happens if you have an equation that looks like this? How can you solve this equation? X squared x in some number. Well, this is a quadratic relation. So what we can do is use the quadratic formula. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. If we ever want to find the values of x, we can use the quadratic equation if we see that it's got an x squared, x, and some number. So I'll write down my values of each. B is 20. A is negative 4.9. And C is 2. So now what's left is to sub in our values in this equation. Try that and check your answer with what I get. So you plug your values into the equation, the quadratic equation, and you should get 2 answers because there's a plus or minus here. The first one is 4.2. The second one is negative 0.098. Now remember, this x that we said, that represents the time that it takes to hit the water. So we've got to look at this and really understand what these 2 values mean. This is saying the time is equal to 4.2 seconds. This is saying the time is negative 0.098 seconds. So this answer doesn't make physical sense. Negative time. So we can ignore this answer and say, okay, this must be the value that for how long it takes to hit the water. So we're going to ignore the value that doesn't make any physical sense and go with the one that does. So we just found the time to be 4.2 seconds. Now time doesn't depend on direction. So it's 4.2 seconds in the x direction, but in the y direction, but it's also 4.2 seconds in the x direction. So now that we found our time, we look at our x direction and we say, okay, I have 1, 2, 3 variables, so I can always find a 4th. Now, same variables as before, so I'm going to use the same equation, but instead of y's, I'm going to put x's. So delta x, vix delta t plus 1/2 ax delta t squared. Now you can plug in your numbers and find that this term over here is going to be 0 because my acceleration is 0. So I can just ignore this whole term. 0 times any number is just going to give me 0. So now all I have to do is multiply those 2 numbers. When I plug into my calculator, I find 145.3 meters. So this is the displacement in the x direction, which is how far from the base of the ship does the cannonball land. So we're done.